Hi, good evening, everyone. My name is Aman Sharma, and please excuse for this particular voice. Having some cold, and that's the reason for this particular problem. This particular webinar is a different one because I have to present the webinar, and I am the host as well. And this is actually due to a change which has come in terms of the way the Google Hangouts actually used to work. So we'll not spend time discussing how the Google Hangouts used to work and what change actually have come. But this webinar is in the continuation of the webinars which we do on the behalf of the North India chapter of All India Oracle Users Group. Let's move on. So this is about me. This particular page tells some things about me. So my name is Aman. I'm an Oracle ace. Um, I am a part of the All India Oracle Users Group. I serve on the board of the Oracle Users Group, and also I am the founder as well as one of the leaders in terms of the North India chapters, in North India chapter of the All India Oracle Users Group. I have co-authored 2 books. I am certified in a couple of certification tracks, and I have been doing Oracle for quite some time. And also, I am I'm a contributor to the Oracle database forum, which is on OTN, and I have been over there for quite some time as well. So this presentation is basically about what? This presentation is basically about how the select statement actually works. And the reason for having this presentation created basically was that this presentation is actually an answer to a question which I get quite a lot of times, that when the select statement is going to be executed, what are the things which are going to be there happening behind the scenes. So it is not entirely the details of all the nitty-gritties working behind the scene, but yeah, it is still having quite a lot of stuff covered. So this is just a quick overview of how the things are in the database instance. So you can see that in the database instance, there are many things which are actually there. There are a lot of memory components, there are processes, there are different sort of files, and so forth. And of course, when the applications are going to connect, it is going to be interacting with the database with lots of communication between the database listener process as well as the listener process spawning a server process and so forth. So the most important component in terms of this entire instance for the sake of script query is going to be the shared pool. And that's what we are going to discuss in this part, because shared pool is exactly the home of SQL statements. There are many components in the shared pool, but the important component which is going to be about the SQL statements is going to be the library cache, which is one of the sub areas of the shared pool. So shared pool is basically going to be a very important structure of the database STA, and it is going to be now mostly controlled with the help of either automatic memory management or automatic shared memory management. Now, I just put up this particular thing because it is like a demystifying thing. So shared pool is not exactly what mostly people actually think of. Most of the people actually have the idea, or at least they assume, that shared pool is containing the library cache, the row cache, which is also known as data dictionary cache, and from the 11G onwards, something called the result cache. But shared pool actually contains many more structures inside as well. So this is basically just a quick query which I put up over here in the form of result, that in the case of shared pool, we have got nearly 890 structures inside. And that is the reason shared pool is basically a metadata structure. The meaning is that lots of components which are working in the database, their metadata is actually going to be stored in the shared pool. So shared pool is maintained by a component which is known as KGL, the kernel generic or even general library cache manager. And that is why most of the internal tables which are going to be there in the shared pool, their names start from KGL, KGL OB, or so forth. So shared pool is basically having its memory configuration different compared to the buffer cache and some other structures, because most of the structures actually are going to be having the memory configuration done, or you can say memory allocation done in terms of the database block size. But in case of shared pool, the allocation done is in terms of chunks, and these chunk sizes are actually defined to be of 4 kilobytes. Right? So this particular chunk allocation has to be actually contiguous, and that's the reason in case Oracle cannot have the allocation available in terms of contiguous manner, which is actually possible in terms of the partial manner as well. But in terms of the allocation, which is not possible in terms of contiguous manner, it is actually going to be resulting in the ORA 4031 or 4031, which basically is going to be telling that, in terms of the shared pool, certain chunk of memory is allocated and certain chunk of memory is not actually sorry allocated. And that is going to be resulting into an advice which is again very common, that shared pool allocation, and you don't find the memory shared pool allocation requirement, and one doesn't find the memory in the shared pool, go ahead and flush the shared pool. The shared pool is actually a little bit complex in the internal working, and this is what basically is going to be two components which are going to be there in the shared pool. So one part of shared pool is basically made up of something called the permanently allocated portion. Now this portion is going to be allocated by the database itself, and this portion is going to be controlled by the fixed size, which is going to be there, which is going to be allocated by the system. Now this allocation is based upon a couple of things like processes and sessions and so forth, and these particular allocations are actually not going to be controllable by a DBA. Right, that means in case a DBA wants to change this permanently allocated portion, it is not possible. The other part of the shared pool is going to be the dynamically allocated portion, which is actually going to be set up by the shared pool size, and that is going to be containing the components which can be useful to the DBA or to the performance engineers, like library cache and row cache. Now, the allocation of the shared pool in terms of the memory is done in terms of something called classes, and there are 8 classes, as in terms of 12102 at the moment of this particular presentation. So these classes basically are of different types of nature. You can see some of the classes are actually mentioned with the keyword with the character R, which is actually going to make them as something called the reserved classes. So I'm not really going to go into the detail of this particular entire thing. It is just a thing which I mentioned over here, that shared pool is not just library cache and data dictionary cache. It contains a lot more stuff. So these classes basically are going to signify one thing, that the reserved components in the shared pool, or the reserved chunks in the shared pool, are actually not going to be getting deallocated or getting flushed out when you're going to be giving a command of alter system flush shared pool. And if you want to see this particular chunks, you can actually see them in a table external KSMSP. If I remember correctly, it is kernel server memory shared pool. And this is a table which is highly not suggested to be accessed in terms of a production system, because Oracle doesn't release the latch until unless the entire structure is not going to be actually accessed. So it's not a good thing to actually access this table in a very busy production system. It may cause entirely the system to be hung. Now, this is where we actually start with the, excuse me, is where we start actually with the SQL statements execution process. So normally, whenever we talk to, we talk with anyone, most of the times they say the SQL statement is going to be processed in terms of 3, things. Something called the open cursor, and then fetch cursor, and then it's going to be the close cursor. So in a very quick format, that's what we normally say: open, fetch, and close. Though it's not really incorrect, but it has got a little bit more things added to it, and that's what I have tried to put up over here. So the first thing is, when we talk about the open cursor actually starts by creating a cursor which is going to be on the client side. Now, this basically means that the the cursor allocation or execution is actually going to be a 2-part thing. There is one part of cursor which is created on the client side, and there is a second part of the cursor which is going to be created on the server side. So when you're going to be asking a query to be executed, that execution actually starts from the client because of the obvious thing. The client is the one which is going to be actually starting with the execution, or will be giving the request for the execution of the query. So this client-side cursor creation will lead to the search on the server side for a matching cursor to be found, which essentially means if I write a query on the client side, for example, squad.emp, that particular query, if it has a matching query found in the server side, that means I can just reuse that particular matching statement, and that statement can be now executed by me. Now, this is something which is going to be a 50-50 kind of thing. I might find my query over there in the server side, or I might not. And what is going to be happening in both the cases is going to be different. So if I do find my query, which I'm looking for, I need to know that the query which I'm trying to look for has to be found out in the exact match, which is actually requested by the client. So when I'm going to have this match found, this is going to be a different path of the things, and if it is not found, it's going to be a different set of things which is going to be executed. Now, in terms of the query being found, that means all the necessary things which are required to execute that particular query which the client has requested are already found in the database. And that means all what you have to do now is just reuse that particular cursor and move on to the next phase, which is going to be executing the cursor. But what if the cursor is not found, or maybe the cursor is found, but it's not in the same form in which you are actually looking for? For example, you might have, and I'll show this example to you in a minute, that you have given the query in terms of one particular case, for example, lowercase, but the query which is found in the server side shared pool is in the different case, for example, lowercase compared to the uppercase which you have written. Now, in that case, even though the query is found, it's really not actually going to be something which you can use, because the query has to be identical in order to be called as shareable. So it has to be a completely identical query before Oracle can actually mark this query as a shareable query. So even though the query is going to be identical, sometimes it may not be actually shareable. So we'll see this particular part in a minute. So in case the cursor is not found, or even if it is found, but you can't really actually use it, it's not a shareable cursor, then Oracle has to go ahead and open a cursor, where the actual step which we discussed previously called open cursor is going to come into the picture. So the open cursor, when it is going to be happening, that means now there are some more things which Oracle has to do to ensure or to understand how this cursor should be actually executed. And that's where it's going to be the part of the parsing, of the bind, of the parallelism, and so forth, which may come into the picture. Now, the bind and the parallelism of the query, they are actually optional, and that's the reason I put them in the dotted dashed format. Now, after the parsing is over, and it is probably going to include binding or probably not, but once the parsing is over, that means now the query can be actually executed. And this is the same thing which is going to be there, even if the cursor is actually found and it's actually a shareable cursor. So both are actually going to end up in terms of execution, and the execution is now going to be resulting into the fetch of the data, from the server side to the client. And once the fetch is done, when the first fetch is over, that's where the cursor is going to be closed. And this closing of the cursor is going to be done on the client side. That's what basically is going to be the thing, that the cursor is not flushed out of the shared pool just because the cursor is now executed completely. So Oracle will actually make the cursor still available in the shared pool, and that's going to be based upon the AIOUG algorithm, which is going to be there in the shared pool. So that doesn't mean that just because the cursor is executed, it's now going to be thrown out of the particular system. Now, this is going to be the search process, because that's where we actually have the cursor has to be found first. So if the cursor has to be found first, that means there are certain things that Oracle has to do in order to ensure that whatever we are looking forward from the shared pool, it is exactly available to us in the system. And that's where the check for the query actually starts. So as I said to you, the cursor creation starts from the client side. So on the client side, or you can say for the client side, we have got the PGA available in the system. And that PGA contains a component called user global area. And that user global area is going to be used by Oracle to basically find out something called the syntax check for the query. Now, the syntax check of the query is very simple, and the meaning of that is the syntax check is to check whether the syntax of the query is correct or not, which means if the cursor syntax which you're writing, sorry, statement syntax which you're writing is not correct, that means Oracle is actually going to just stop the query's execution and it's not going to move forward. The next part is going to be the semantics check to check for the object structure, to check for the privileges of the object, and so forth. And after this, the query is going to be converted into a hash. So the hash is going to be generated for the particular, for the particular query, and that hash is required because the search for the query in the system is going to be based upon this particular hash number, which is going to be generated for the query. So now we have the query available, and that particular query is going to be searched in the library cache component of the shared pool. And again, this is where we actually had the discussion done in the last slide, that this is going to be resulting to us in terms of the cursor being found or cursor being not found. If the cursor is not found, we are going to mark it as a hard parse cursor. But if the cursor is found, it's going to be considered as a soft parse cursor. And the meaning of soft parsing is we really don't have to do much. We can just pick up the query and just execute it right away. So we just mentioned a term called latch. So just briefly to put that, latches basically are low-level serialization processes, and their basic use actually is to give two basic benefits to the user. It's going to be for locating a resource which is available in one of the memory components in the database server, and the second part is once the resource is located, to lock the resource till the time it is not marked as not useful to the particular requester. So the latches are basically available by the Oracle to implement this thing, that how exactly we have this resource that we're looking forward to be found, and once it is found, how exactly we can lock it so that that particular resource should not be tampered with or should not be deallocated from the memory of the database server. Now, of course, there are going to be so many memory components with shared pool, buffer cache, and so forth. And for all the memory components, the latches actually exist dedicated to them. And since the systems actually have become so larger now, so it is really not possible that just one latch is going to be enough. And that's why the system is going to be having sorry, multiple latches in terms of the database environment. So for one particular latch, there may be several children which may actually exist. And of course, this particular concept is getting into the changes now, because this is going to be giving us something like a false contention. Reason being is that before we actually get to know that, sorry, we have our resource available in the memory, we have to make sure that the latch that we're looking forward is actually available for us or not. That means whether we actually are able to find the query in the shared pool or not, that's going to be only possible, or that's going to be only possible to be searched once we have got the library cache latch actually available. So once I have actually got the library cache latch, then only I can go ahead and search for the particular query in the library cache, which means rather than actually waiting for my query, or rather than actually looking for my query, what I'm actually looking for, first of all, is the library cache latch, which is another overhead on my side, besides actually looking forward for my particular source, which is query in this example. That is why the latches are actually considered as a false contention point, and that is why Oracle is moving away from the latch concept, and they're using a concept which is similar to how the OS allocates the resources, called mutexes. So just like I said, that latches actually have become a contention point, so Oracle is moving away from the latches. So it's just a quick example that there are several latches which are basically there in the previous version of the databases, and you can see that this is an example which is there for 10G, that we have got like 7 latches which are going to be there for library cache itself, and these latches actually do a lot of stuff for you. So it's including the pinning of the cursor to the allocations and so forth. But in terms of 11G, we have got the same thing available just by one latch. Sorry, the one latch, which is the library cache load lock. So this latch is basically the only latch which is going to be available to you from the 11G onwards. So that means the idea is that with the help of mutexes, Oracle is trying to bring down the number of latches which are actually required to function. And this is basically going to be the path forward which Oracle is actually going to be using. So moving on now to the library cache itself. So library cache is one of the major components in the shared pool. Again, library cache is going to be a part of the shared pool. So the exact size of the shared pool, or sorry, library cache is going to be done by the shared pool itself. But since shared pool is going to be further divided into something called a hash table, so Oracle is going to be having some parameters like the parameter bucket count, which is going to be there for the particular library cache. So this is going to be actually telling how many number of buckets are going to be there for the particular library cache. Now, library cache is going to be a very important component in the shared pool because that's where the allocation of most of the components which we actually use in our day-to-day work, like SQL queries and procedures and so forth, are actually placed. So library cache is again going to be having two parts which are going to be generated for it. One is going to be for the store objects and a permanent part, and the second is going to be a temporary part which is going to be there for the components which actually can be flushed out. For example, the cursors. So the shared pool is sorry, the library cache is basically going to be having the components which can be part of it named as something called namespace. So the idea of namespace is basically those chunks or those set of things which could be a part of the shared sorry, could be of the library cache. So like I said over here, that in terms of library cache, the namespace, SQL area is one of the major things which is going to be there. And SQL area is, of course, the most popular component in the library cache because the most popular thing to execute is actually the SQL query. So this library cache is actually going to be divided into, again, something called a hash table, which is comprising of the hash buckets. And again, the same mechanism which is going to be like searching for a query is going to be there, is going to be a part of this library cache. Actually, the search for the query is done in the library cache. So this is where we actually have to do this found and not found kind of activity. So library cache is going to be a part of something called hash table. This hash table is having a couple of buckets created. So the buckets are going to be there, and these buckets are basically going to be having lots of library cache objects, which are actually going to be linked in the library cache hash buckets with the help of their handles, which are going to be called as the object handles. Now, since we're not really talking about the other things, we're really talking about just a query. So if you write a query and the query's hash is going to be generated, essential thing which Oracle does is to look forward for the query in the particular hash bucket. And that particular hash bucket query which is going to be there, that is going to be searched for a matching SQL. So what I've tried to actually show over here, that for the particular query, there may be multiple variations possible, and those variations are actually listed over here in terms of these rectangles which I'm creating. Now, search will be done by Oracle to find out the matching cursor for the query. If the cursor which they are looking forward is found, that actually is going to be considered as a soft parse. But if the particular match is not found, of course, that's going to be resulting as a miss, and that will be actually causing something called the hot parse. So the basic thing which is going to be there is that library cache is the component which is going to be searched by Oracle to find out whether the query is available or not in the system. So here is just an example of how can you see beyond the views, and you can actually go into a lot more detail about the library cache. So you can have the dump of the library cache possible by the command alter session, and you can also do the same things by Aura debug as well. So this is just an example which I've done, and got a small output actually put up over here, which is basically for a query which I have actually, for a statement which I've actually executed in one of my examples, which I'm going to show you next. So you can see that in this example, we can see a particular object which is created. We can see its hash, which is actually there. We can see that it's a part of the namespace SQL area. And we can also see that Oracle is having a few handles, and it's a part of a particular bucket and so forth. So total count of the lock, total count of the pin, which is there for the particular query, is actually also shown to you. We can also see the invalidation count of the query. We'll talk about invalidation in a minute. So basically, the idea is that this is just to tell that library cache is going to be the major area where the entire work actually happens. Now, the important thing, or you can say the interesting thing about the library cache is, or even we have just mentioned over here, that we have something called the cursor searched in the library cache. So what exactly is a cursor? So cursor is basically a kind of memory area which is created by Oracle, where the execution, or you can say where the compilation or compiled information of the query is actually going to be stored. So the cursor which is going to be there is basically going to be having two variations possible. So a cursor could be a private cursor, which is going to be a non-shared cursor, and this is basically a cursor structure which contains that information which is not shareable by the users. So you can see over here that I mentioned that this particular information is going to be cursor information which is going to be part of the PGA. So within the PGA we have got something called the cursor global area, which is actually the structure where this cursor allocation is actually going to be done. So this information is basically going to be a user specific information, and of course being a user specific information, this is actually going to be a non-shareable one as well. And again, this is going to be created by either implicitly or explicitly for the queries, depending upon how you basically parse the query or how you give a parse request for the query. The second part of the same cursor is going to be the public cursor, which actually we are mostly concerned with or interested about. That's going to be in the part of the shared pool. So this is something which is going to be actually looked forward by Oracle to decide whether they will be going for a soft or a hard parse. And of course, the soft or hard parse cannot be just possible because the query is found or not found in the library cache or in the memory. It could be even possible that the query is found in the memory, but it is still not shareable by Oracle. So basically, this is actually the concept of the shared cursor. And the shared cursor concept basically means the query has to be an exactly matching query, which you're looking forward from your particular client interface. So the query the shared cursor which is going to be created in the library cache is going to contain many things. It's going to be containing the text of the query, the plan of the query, and so forth. And it is also going to contain a lock, which is actually going to be called as breakable parts lock. The idea of this lock is that anytime if a hardware change, structural change is going to be done on the particular object, Oracle will mark the cursor which is already found for that object as an invalid cursor, which is to illustrate with a simple example that if I have a table and I add into the table a column, now I have actually done a change. Or another example, I think that's a more better one, that if I have a table and I run the query on the table without having an index, it is going to be resulting into something called the full table scan plan. Now, if I make an index on that particular table and then I try to run the query on the table, of course, it's not a guarantee, but it's actually going to be a kind of assumption that it is possible that for the query, Oracle may actually use the index. And that is where the breakable parse lock is going to come into the picture, that because there is a possibility to have the index being used, Oracle will actually mark that previously cached plan as invalid, and it is going to be resulting into the reparsing of the same query. Now, the cursor which are created in the shared pool or in the library cache are actually going to be of further two types. So many types actually, but there are going to be further two types: parent cursor and a child cursor. So what exactly are these parent and child shared cursors? So a parent cursor is like a template, which means if you write a query, of course, the writing of the query is going to be resulting into a template kind of thing being created. And this template is the first thing, or you can say the first most thing, which is actually going to be created for the particular query. The parent cursors are listed in terms of this particular public view and this internal table. And in terms of the child cursor is the executable portion of the particular parent cursor, which means every parent will at least have one child, or you can say every parent will be of its own child, depending upon what kind of variations are possible for the query. So for example, if I write a query by simply saying select star from EMP, of course, this particular query cannot have any further variation possible. So that means this is going to be resulting the same query which is actually used as a template to be actually executed as well. But there are possibilities that there may be one parent having multiple children created, and that is going to be due to the variations possible in the parent cursor due to the inputs given by the user or due to the variations done in terms of the environment available for the execution. Now, of course, when we say that a query has to be found or is supposed to be found and matched, that means we are looking forward actually for a parent cursor, sorry, a child cursor to be actually exactly matching. So it is a possibility that you may find a parent, but that parent's child cursor or the child variation is not exactly what we are looking forward for the particular query's execution. So this is where the concept of the shared cursors actually come into the picture. Now, the cursor, which is going to be a shared cursor, or the information of the shared cursors, or why the cursors are not being shared, that is going to be available to you from the view Visual SQL shared cursor. So here is an example that I've actually created, pretty simple example. So you can see that I'm running a very simple query, which is actually select star from T, and there's no change in the query. It's running in the same session, and you can actually notice that select star from T is basically running one time with the uppercase and the second time in the lowercase, or first time in the lowercase and second time in the uppercase. Now, normally speaking, we always get to hear that the queries are actually case insensitive, which means there is no trouble in terms of writing the query in this way. But it is actually really not the case. It is actually a trouble for the system. So we can see now that for this query, Oracle actually has created for us in the parent cursor view of two cursors actually. And you can see that these two cursors are separately created because the SQL IDs for them are separated, and even the hash values of them are actually different. And now if you check for them, the version count is 1, which basically means the particular set of queries are executed, or you can say stored independently into the system. They're not being something which is going to be a shared kind of thing. Now, if you check for them, the child cursors being created, you can actually notice that for each parent, there is one child, which is actually shown over here in terms of CSR number. There is one child which is actually shown to you. That for each query, a child is created. And this is the reason, and this is because of the reason that each particular parent is actually running its own child, and the children are not shareable because of the different case of the query. Excuse me. Now, this is another example. Now, if you notice that in this example, what I'm trying to do is I'm running the same query select star from T, but the query which I'm running is running in the same session by two different optimizer modes. So the one mode is the first rows, and the second mode is actually choose. There is no change in the case of the query. The case remains the same, but I've changed the optimizer's behavior by the mode, which is actually mentioned over here. And now if you do notice, the particular number of parent cursors created is reduced to 1, but the version count created for the parent cursor is now shown as 2, which basically means that this parent is executed twice. That means there are two separate child cursors created for this particular parent. And we can see actually that there are two child cursors created. Now, of course, the reason we have to find out that what exactly is the reason for this particular child cursor creation is. And as we mentioned already, that this is due to, this is what we can actually see from the $SQL shared cursor. Since it's a very controlled example, and I already knew that this particular reason is basically the optimizer mode mismatch. So I've actually mentioned in this particular example, in this particular query, the optimizer mode mismatch as the reason, which is actually shown to me over here as yes, which is done for the second execution. That means the cursor which is supposedly to be found as matching, that has to be matching exactly. And if it is not, that is where the cursor is going to be marked as unshareable by Oracle, resulting in multiple cursors, child cursors being created in the library cache. Of course, these things are taken care to a very large extent from 11.2 by help of adaptive cursor sharing and so forth. And we have some parameters like cursor sharing and so forth being available. But this is an important thing in terms of query execution. So there are so many reasons which could be there in terms of the SQL shared cursor. I've mentioned over here the reason column. This is the column added from 11 to 03 in this particular view. And the reason for that, the name of this column is called reason because it's actually easy for you to find out what exactly is happening for the query by just querying the CLOC column and not exactly to search out in this whole list of 20 plus columns that what exactly is yes or what exactly is no. So the basic questions answer that what exactly is a cursor is basically like a bridge which is going to be there between the client's PGA and which is going to be between the server side. Now, once the query is going to be decided to be either found or not found, that's going to be resulting into the second part of the execution, which is going to be the parsing. So that depends upon something called, that depends upon the query search. If the query search is found, that means it's going to be a hard part. If the query is not found, it's going to be, if the query is found, it's going to be soft part. If the query is not found, it's going to be a hard part. I'm sorry for that. Now, hard parsing is something which is unavoidable, and hard parsing is something which is going to be actually telling to the Oracle database engine how to actually execute the query. Now, this particular hard parsing is basically done by a component in the database called optimizer, and that's what you can actually see. The optimizer in terms of database is now the cost-based optimizer. The cost-based optimizer basically means that this is the component which is actually going to decide which method or which way is the best way to run the query. So optimizer is something which is going to be actually deciding the way to execute the query by going through different set of steps for the parsing of the query. So the hard parsing is basically something which is done by Oracle to first of all find out what exactly is happening, and second is this is an unavoidable step at least for the very first time for the query. So which means for the first time of the query, it is always going to be a hard parse. There is no other alternative. So hard parsing is basically going to be done by Oracle to do many tasks. For example, to validate the query, to create a plan, to find out the plan, to calculate something called cost. And hard parsing is also by itself a costly operation for the simple reason because even hard parsing is going to have some processing involved, and that processing is going to be consuming the resources such as CPU. So this means the hard parsing is something which is actually supposedly to be done as less possible, in the database in the query's execution. So the ground rule basically is the query should be passed once and executed many times. But again, as I mentioned, it's something which is going to be depending upon the factor that whether the query is a shareable query or not. Now, in terms of the hard parsing, the very first step is going to be the query transformation. So this query transformation is something which is in a very simplified way is to make the query as simplified as possible so that the query can be converted by Oracle in terms of like a simple select and simple from. And the example of this can be query rewrite. There are different transformations possible. The query rewrite is basically done for the materialized, for the query having a materialized view available. So the idea is that if let's suppose we got a 10 table join and the 10 table join is happening on very large set of tables, this is actually going to result, the tables to be scanned all the time and the result to be computed again and again and again. Rather than doing that, what we can do is we can store the result of that query in a table called in a view called materialized view, also known as summary tables in the past. And that particular view is going to hold up the data. Now, it's going to be a good thing that Oracle can check this thing that for a given query having 10 tables involved, is it possible to send the result of the query and get the result of the query from the materialized view, which is going to make the query more faster because Oracle does not need to compute the result. So the result which we're asking is already found in the particular materialized view. Now, this essentially, if you look at, is going to make the query converted into a simple select and a simple from. And this particular transformation is going to be helping out Oracle in order to go for the next step, which we'll discuss just in a second. And that is going to be the estimation of the cost, which is going to be there, or which is going to be supposedly incurred by Oracle to run the query. So the transformation is something which is depending upon the query writing or the inputs being available. So it's not mandatory that the query has to be transformed, but yeah, if it is possible, they will definitely try to do that. The next step after the transformation is going to be something called the estimation of the cost of a query. The estimation of the cost of a query basically is what amount of system resources Oracle is actually thinking, mind the word thinking, to actually execute the query. Now, why we say thinking? Because the query has yet to be executed, which means Oracle still does not know whether the query is actually going to incur this particular cost, or it's going to be some other cost, or maybe some more cost. Because the query's cost is going to be given or calculated based upon the input given by the user. Now, the cost of a query is calculated by two things, which is going to be selectivity and cardinality. So the essential idea is that when you ask for a result to be found from the particular table, that particular result is going to be found by deciding that based upon your given query, how much amount of data is actually supposedly found from a particular table. And that is what is going to be making the query either high cost query or low cost query. For example, if I search for the entire table, obviously I will be incurring more resources. And if I look forward for less number of rows from the table in my result, it is going to be incurring less cost because obviously my query is going to be producing a smaller result set. And the final thing after the estimation phase or the costing calculation is over is actually going to be the searching for the plan, which is going to be the plan generation phase. And the idea basically is that based upon the cost, which is calculated in the second step, Oracle is actually going to try to find out that for that particular cost or in that particular cost, what are the permutations possible, for the particular query to run. That means how many plans are exactly possible, for that query. So this is where some details of the things are. So I mentioned transformation phase is basically to transform the query. The estimation phase is basically for the selectivity and for the cardinality, which is basically going to be there for the cost of the query. Now, selectivity is, as I said, is the amount of the information that we're looking forward from the particular table. So you can see that it's going to be part of the table itself. That means Oracle is going to decide this thing from the table. That means the information of the table stored in the data dictionary, which is known as statistics, is going to tell to the Oracle that what is the selectivity going to be there. The selectivity estimate is going to be in the range of 0.0 to 1.0. And this information is going to be used by Oracle to decide that how the things are going to be in terms of the actual number of rows which Oracle can actually search in the, or Oracle can actually assume to be found in the particular table. So there are different formulas which are going to be there for different predicates. Like for example, I've just mentioned for equal to sign. So for the equal to sign, it's going to be 1 by number of distinct values. Now, this is just an estimation that, okay, this is what we're expecting from the particular result to be there from the table, but the number of rows which you are expecting is going to be coming from the cardinality. So the cardinality is going to be the selectivity into total number of rows, which means it's going to be the number of rows which you're expecting from the query to be actually found. So of course, this is very important because basically this particular thing is going to be helping us to figure out that when we're looking for the result from access from the table, what exactly is going to be happening in terms of the table's statistics. The problem is that sorry, cost of a query is not just the access of the table or the object. The cost of a query is essentially going to be also using the system, which basically means that it is also going to be that in terms of the system, how exactly the system is going to be executing the query and what exactly are the resources which are going to be there in the query. So this basically is going to be based upon the system statistics. So this is what I've tried to show over here, that the cost of a query is shown to you as like percent CPU, because the cost of a query is calculated based upon the time spent, or you can say the CPU spent to execute the same query. But it can be changed, and that's what is possible. That it's going to be possible by a parameter called optimal cost model, and you can see that the default value of this particular parameter is CPU, and that's the reason it is actually going to be the CPU shown to you over there. But one thing which is important, that the cost of a query does not represent the elapsed time of the query, which is actually very important to remember. So if you see 3, that does not represent 3 seconds or 3 minutes and so forth. So what exactly is the cost then? So the cost of a query is basically calculated by Oracle by this formula. So it's going to be the single block reads and the time for that, multi-block reads and the time for that, the CPU cycles and the CPU speed and the single block read time, which is basically meaning that the particular query is query cost is actually going to be the single block read seek time, which basically means that Oracle will evaluate the cost of a query by deciding or by estimating that how much it is going to be taking time to read one block from disk to the cache. And of course, because these statistics are not just the object statistics, they're actually going to be part of the system. So they're actually listed in an internal table, which is going to be the aux_stats $table. And this is important because if the statistics of this are not there, then Oracle actually calculates the same thing by using something called no workload statistics. And the no workload statistics actually are the statistics which are basically just guessed by Oracle. They are actually used by Oracle based upon the guesswork. So they will assume certain values. For example, multi-block read count is going to be 8 in that guessed number, and it's not probably the number which exactly the system is going to be using. The system might actually use a larger number. So it is something which is going to be decided by the system, but definitely can be should be changed actually by you, right? So That's the idea which is going to be there. Now, this is important because the cost of a query is going to be or should be including both the object statistics and the system statistics. So if the object statistics are going to be not there, Oracle can still take care of this by using something called dynamic sampling. So dynamic sampling is going to be a method which Oracle uses to figure out that how exactly the things are going to be in terms of the system. So dynamic sampling is something which is going to be deciding this particular cost calculation, sorry, stats calculation at runtime of the query. There are some changes in this. So from the version 12c, there is a separate level which is called level 11, which is there. And even this is having some problems because it may be possible the particular query which you're running, the particular query is having the information already available to the Oracle and the stats already calculated. But when the query is going to be running, that particular information is now stale. So what I mean to say is that the query is supposedly containing 100 rows in the table, but there are 10 more rows inserted when the query actually ran. So there are actually 110 rows. That means the information stored in the database dictionary and the information which is available at runtime, they don't match actually. And that means that the information has to be checked and has to be corrected, which is going to be meaning that we should be keep on gathering statistics again and again. And Oracle is trying to take care of this thing from the version 11.2 with the help of the feature cardinality feedback. And that particular feature is basically going to be having another variation possible with the help of something called the statistics feedback. So you can see that this particular thing is going to be shown to you in terms of the view, different views. And another example of this, or another way to actually compare this thing is going to be having the hint called gather plan statistics. The gather plan statistics hint is basically a hint which is going to be used by you in order to find out the variation between the runtime stats and the stored statistics. So it's actually a hint which is very useful. It is something which is actually going to be quite good to figure out what exactly is going to be the difference between the particular runtime stats and the stored stats. And the number of the permutations are based upon the statistics. So that's what is going to be the number of plans. So the number of plans actually are decided by internal parameter, which is optimizer max permutations. So optimizer max permutations is set for 2,000 by default, and this number is actually 80,000 in the previous versions. Is set for 80,000 in the previous versions, right? Now this number is not required actually to be changed by you because this number is something which is already a big enough number. It's 2,000, so it means that there's a fairly large number of permutations that Oracle can actually compute. But again, this does not mean to say that the number is going to be 2,000 all the time, because it essentially depends upon the form of a query. So for example, if you write select star from EMP without any kind of other things possible, that essentially means the query is just going to be select star from EMP. So there is no other permutation possible for the query. Now, on the contrary, if you write a join clause and if you write a 3-table join clause, that means for the same 3-table join clause, there are 6 permutations possible. So for example, table 1, 2, 3, or table 2, 3, 1, and so forth. So that means for the same particular query, there are 6 permutations actually which are going to be possible. So of course, out of these permutations, Oracle picks up that permutation which is going to be giving the least cost to the particular query. And this is what is visible to you by the 10053 trace event. So 10053 trace event is basically going to be there, which is going to tell to you, if you look into the trace file, that how exactly the query, how actually the optimizer decided to go for a particular query plan. Soft parsing is obviously now, I think, should be understandable much better, because hard parsing is definitely going to be causing lots of system resource consumption. So soft parsing is simply we just pick up the query and run the query, and this is something which is going to be of course better, because all what we have to do is search for the query, find a match, we're good. And soft parsing is, I mentioned, slightly better because it still requires the search to be done in the library cache, which is not so time consuming, but yeah, it is still time consuming. So the best way to actually run a query is to actually do the no parsing, so which we'll discuss just in a minute. But the soft parsing is something which can be done or can be created by the help of something called the bind variable. So the bind variables, which are basically going to be there, are either can be created explicitly by you or by the help of parameter cursor sharing, or they could be present from a developer by giving the bind variables in the query. So bind variables are going to be having the performance impact depending upon, again, whether they actually make the query shareable, or they will be having the query marked as unshareable. So unshareable, I should not say, but whether they're going to give you a query plan which is actually going to be good for all the variations of the binary variable values, or whether they are going to give you, a kind of environment where each particular query's execution is going to require a different plan, but you don't get that because the cursor is going to be shared. So the idea is, if the cursor is if a plan is created for one particular binary variable value, and that plan is supposedly good for like 90% of the data sets or data values of that particular bind variable, that means they're going to give you good performance. But for every value, if you actually need a different plan, because of the bind variable, the plans are actually going to be the plan is actually going to be shared for all the subsequent executions of the same bind variable cursor. This is going to be resulting into a bad performance now. So this is taken care by something called adaptive cursor sharing, a feature from 11.2, and also changed in 12c. So there is a little bit change done for that part in terms of 12c, called adaptive optimization kind of thing. So the idea is that hard parsing and soft parsing both are having their own pros and cons, but the point is that there should not be any parsing at all, and that's what is the thing which I mentioned, that there should not be any parsing, and that is actually done by something called the no parsing clause. The no parsing is done with the help of a parameter called session cache cursor, which is actually set now by default, and this is going to be happening in case the particular cursor is actually searched for 3 times. Though it's really not 3 times, actually third time is going to be the hit which they're going to be looking for. Only in the 2 times itself, they can actually decide that they will be going for this no parsing concept. They put up a lock on the cursor in the second part itself. But you can just say, for the execution's sake, that it's going to be 3 times, which is going to be there. That if the parse call for the query comes for 3 times, that means the particular query is marked as a no parsed query. So the session cursor cache count is going to be the number of cursors which are actually marked as these kind of hot cursors, and the hits, session cursor cache hit statistic, is basically the number of hits which have come up for that kind of cursor which is marked as a hot cursor. So the idea basically is that Oracle is going to be optimizing the cursor for the first call. At second call, they will actually do the authentication, check for a statistic called cursor authentication statistic. And that basically means that the particular cursor is basically marked as going to be a part of this soft parsing in the second call itself. So at third and after third execution of the same cursor, the statistic of hit is going to start increasing, which is basically going to be meaning, if we check from here, that there is no lookup of the library cache hash changes required, because Oracle can simply go ahead and pick up the cursor from the address which is going to be stored in the PGA for the same query. And that is basically what we mean by the hot cursor. So rather than searching for the query in the library cache, the client is going to be told that where exactly the query is found in the library cache, and they can just pick up the query from there and they can execute. So this is even faster than it is going to be the soft parsing. So what exactly after this parsing phase? So after the parsing phase, it's going to be the execution, which means the query is going to be now executed. And execution basically means the result is searched, whether the result is available in the memory or not. If it is available in the memory, good, because that's going to be giving you a logical I/O. If it is not, then the result has to be pulled in from the disk. Once the result is pulled in from the disk, it has to be given back to the user, which is going to be the fetch. The fetch is controlled by an array fetch, which basically is the number of rows which are going to be returned to the user in one I/O trip. And again, this is going to be set up by the client. For example, SQL Star Plus, if the client is using SQL Star Plus, set up the array size in the value of 15 by default. Of course, the number of array fetch, the count of array fetch is important, because The more times you go to the buffer cache, the more times you need the buffer cache latches actually to be available to you. So of course, the array fetch, which is going to be there, has to be set to some larger number compared to the default, whatever you get from your client application. Like a reasonably good number is going to be about 200 to 200 anyways, because it's based on the assumption that more than 100 or 200 rows are really not going to be useful for a client on one single client machine or client screen. So 100 to 200 rows are actually going to be more than enough. And of course, once the last row is going to be given back to the user, that means the cursor is now good enough to be closed. And that's where the execution of the query actually ends. So what exactly are the takeaways now? So of course, it's a complex process. I've actually skipped a couple of things. In the subsequent presentation, probably we'll be discussing how the buffer cache really goes inside, and what exactly happens in the buffer cache, and some troubles, what can be there in the buffer cache, and how we can go ahead and tune them. The second part is the query can be done in terms of, or execute in terms of hard parse query or a soft parse query. Of course, the hard parse query is unavoidable. That means for the first time execution, the query has to go for a hard parsing. Second time onwards, it should be a soft parse, but the better thing is going to be a no parse, which means you should actually make sure that the query is going to be having no parsing requirement actually at all. It should be actually going ahead for a no parse thing. If it has to be a soft parsing, the cursor has to be a shareable cursor, which you have to ensure by writing a query in such a way that it's actually going to be considered as an identical query as well as a shareable query. And also the result can be found in the memory or not. And that is going to be again the thing that the query is going to be having the result found in the memory, or it has to be get up from the disk. The query has to be a good query. If the query is not a good query, or you can say it's not an optimally written query, it is going to be resulting into a suboptimal plan, which is obviously going to make the query slower. And the most important part of the query is the statistics that is going to tell to the Oracle that how to basically run the query, or basically what exactly the query contains. So statistics actually are going to be an important thing. And because of that, the statistics need to be refreshed all the time. The good thing is from 12c, there are many optimizations possible for this. And in a subsequent presentation, we'll be talking about them as well. So that brings us to the end of this particular webinar. I tweet over here, I blog over here. You can reach me on this email address of mine. And in case any questions are there, do let me know. Do give us a feedback on this particular webinar in the form of comments on this particular video of the recorded session of the webinar. Do check our other webinar series which we have done. And hopefully we will be doing one more webinar very soon, and that will be about the Enterprise Manager. So thanks a lot, everyone, and hope to see you guys soon in another online session. Do keep checking our page, All India Oracle Users Group, on the on the website of the All India Oracle Users Group. We do our monthly events in the last Saturday of every month. So we do it in the entire North India. So if you're from North India, do check our Twitter page, do check out our meetup page, and you should be saying that some event is happening somewhere around you. Thanks a lot, and have a good evening.